Good morning, good afternoon, or good evening, depending upon where you live around the world. We return to this series of explorations of the geodesic dome structure, and we left off when I'd created a 3V dome using the, I don't know what you would want to call it, the line array approach, via the division of the base triangle that we use to create these various models. You could call it the porcupine, and you'll find out why in a moment, but it's not really descriptive of, well, it is actually, it is descriptive of what it looks like, whereas this is more prescriptive. Anyway, using this approach, I'll zoom out, you can help in your development create a base triangle and this little doodaggy thing here, because this is the equivalent of the very center. If we go back quickly to this line here, now this only works for a couple of the different frequencies as far as the where it lands here at the intersection of the triangular grid, but it is able to be used for all of them if you lock it in and you only use this to generate or use to spin and rotate the different components or different faces. So while this in this case works out to be one of the rays or lines used to create the surfaces, that can also be used as a point of rotation. So what I do is I draw it out and I put a circle around it to signify that this is the line used for rotation, and then I lock it so I can't move the thing later on, and that way you get to use it without losing it, and it's consistent along with the consistency of the triangle for all of your models. And that's an important thing, because as you'll see, this can get lost in amongst the other lines, or you may use the wrong one, so circling it certainly helps. So while I've been away, I have done a little bit more work. So this here is essentially the shape that I want to work towards, where we've got the legs here and part of the leg structure here as the canopy in the format that I want. But you can see that it's quite leggy or quite tall for its overall dimensions, the width and depth of them. Also, as you can see, looking at it from the side, these legs angle backwards, which I'd alluded to in the previous video about not wanting. I want them flush, or flush would be the correct word, like these are. So this frequency, which is a 4 frequency dome, doesn't give me that. And there's still even a problem when we find one that does. So this is how we created it. We just divided the triangle into 4, popped out the lines where they are required according to the grid, and created a 1, 2, 3, 4, a 4 frequency octadome. This one here, now I've coloured it for a reason. This one works with having the bottom part of the legs flush. Now that's probably the incorrect term, but when you turn it sideways, they'll actually line up. But this part doesn't. So the legs line up, but not this part. So this still is indented, and that's a subject that I'm currently working on, because to generate this in a manner that the maths or the geometry will create, I'm finding problematic. zoom out a little bit. So this was the base upon which I took this. So if I move this back, this is where having a set measurement for offsetting helps, because you can just type in 3 meters and hey presto, you've got your your overlay. So you could look underneath. It's just interfering at the moment. So hide, and there it is there. So it's directly taken from that dome that was created from this. Zoom back a little bit more. We've got this. Now when we zoom in on that and look at it on the side, these ones, while they look flush, are tilted back towards the center of the dome. So you've got to be careful what you're looking at here. I could be mistaken, it's this one, and then you have to come back to this one and use this one to flush it up. But you can also see one of the problems is that while this one looked, as I mentioned, looked quite leggy or tall, this one here is around about where I want to go. This one, acceptable, but your dimension here gets bigger and bigger and your height is reduced. So if this was a very large dome or span, and we'll go into that in another video soon, this would be probably one of the more pleasing visual shapes. So you're looking at the 1, 2, 3, 4, 5 frequency dome. I'll make that a 6 frequency dome because it came from this model. And this is why I was mentioning in one of the previous videos that if you group your items together, you'll be able to relate to what they associate with, and not do what I just did and misassociate them. So carrying on, we come in here again, very, very low compared to the span. It would have to be a big diameter of the base to be able to be used at all for, if the size of this one, you'd be having weddings and restaurants under to make it that big to make it function properly. More waffling. Apologise for that. We've got this one here, which is what? So you can count the 1, 2, 3, 4, 5, 6. It's a 7 frequency dome. And just for good measure, I've created an 8 frequency dome. And now you can see what I was saying about the porcupine. If you want to, the hedgehog or the porcupine, you can understand why with all these lines it gets very busy very fast. Now if I took that one and move it back 3 meters, you can see that the point of rotation, depending on where you are, if it didn't have that circle to clarify which one it is, gets lost easily as you are manipulating, especially when you start to put the other lines on for the surfaces. So we'll just undo that. So that's why that and being locked is a bit of an asset. Now a quick look at this. We've got, this is the same comparative number of surfaces used to create my tent or my pergola, or in some people's call the pergola. But because it gets wider and wider and lower, because it's a smaller and smaller percentage or fraction of the dome, it gets to the point where it's not practical, and the stresses on this would be quite significant. Here, because it's a bigger percentage, as we can see here from the orange area, while it's way more complex as far as the number of struts, it gives you back your height, and the length of your struts become more real world practical. but that's not where I want to go, because the complexity to build that would be huge. It's not something I personally want to do. It might be something other people want to do, but that's not for me, I can assure you. Too complex. So this was just an intermediary video to explain where we're heading, because when we start to expand these, well, we'll do that right now. In fact, I wasn't anticipating doing this, but I'm going to, like this one, I expanded this one by a factor of 3. I'm going to scale these by 3. Now I'll just hide this, hide these. Now that's fine. That's actually quite a pleasing dome. This one is my preferred dome, but for the same scale factor, you're not really going to get people standing under this. In fact, from the, sorry for the joggling around, but if I put a floor in it, the height of the apex to the floor is only 500 millimeters or 550 millimeters, so a bit cramped. Back here on my preferred shape, the height from the apex is 2 meters. Even this is, it's like far too small. You want around about the height of the first leg, the line of the first leg, you want that around 2 meters. 1600 to 1.6 meters to 2 meters, ideally, to give you a headroom. And for the area to be practical, I suggest that this point here, targeted at 2 meters, gives you sufficient room headwise and area wise to make it practical. That's my observations. Depending on what you want to do underneath it and what you want to use it for. One of the things I want to use it for is to protect a car, which I'll show you in a later video. And then it can still be used to pop furniture or landscaping underneath as well. Okay, just unhide everything. So you can see that some of the considerations that you'll have to give when you're building or looking at which one to go with. And as I said, my preferred one is this one here, and that way we can get the best of both worlds. We may have to expand this. We'll look at this one in the next video, and I'll give you a few more design considerations. Rightio, that was it. A wee bit wordy, a wee bit joggly with my moving around inside SketchUp, but we'll come back and we'll progress a bit further with the exploration of the octahedron based geodesic dome. Okay, see you later. Bye.